The apparatus that we use in this experiment is wooden block. The wooden block has rubber cover at one side. Next is 50 gram masses, 10 Newton spring scale, string, and tabletop. Procedure for this experiment. First, the mass of wooden block is measured and recorded as M. Then, the apparatus is being set up as shown in figure 5.2. After that, the tabletop is being made sure stable and horizontal to the ground. The spring scale and wooden block is attached with a string horizontally being placed on the tabletop. The rubber side of the block is face downward. M equal to 50 gram mass is placed on the wooden block. The spring is pulled slowly. Once the block starts to move, the spring scale's reading is recorded. Step 4 until 5 is repeated for 3 trials. Another 50 gram mass is added on the wooden block and step 5 to 6 is repeated. The steps are repeated until total of M equals to 500 gram mass is on the wooden block. Step 1 until 8 is repeated again with the rubber side of the block is being face upward.
So, here's the result for the experiment. We have divided into two sections, which is mass of the wooden block with the rubber surface, which is M equal to 82.48 gram. We have made 10 attempts from 50 gram to 500 gram. And 3 trials, which is trial 1, trial 2, and trial 3. And the last one is average. Same goes with the result at section 2. We use mass of wooden block with non-rubber surface M equal to 82.48 gram. We also use 50 gram to 500 gram. And also trial 1, 2, 2 and 3. Also the average. The differences between result 1 and result 2 is the first one we use rubber surface and the second one we use block with non-rubber surface. For the analysis, we have drawn the free body diagram of the wooden block as shown on the slide. For the second one, we have plotted the graph of static friction force against normal force N for the rubber surface and non-rubber surface. The third one, we use the gradient obtained from the graph to calculate the coefficient of static friction for each surface. For the first one is rubber surface and the last one is non-rubber surface. For the last analysis, we compare and discuss the coefficient of static friction obtained. Based on the calculation and graph, the coefficient of static friction for the rubber surface is higher than the non-rubber surface. The coefficient of static friction of the rubber surface is 5.2 exponent negative 3, and for the non-rubber surface is 5 exponent negative 4. Hence, a rough surface influence in increasing the friction and pressure in this experiment.
Now we will move on to the discussion of these experiments. Friction is the force that resists motion when the surface of an object comes in contact with the surface of another. So, frictional force is the force generated by two surfaces that contact and slide against each other. The formula of friction force is F equal to mu n, which is F is equal to friction force, mu is the coefficient of friction, and n is the normal force. From the plotted graph of the two surfaces, the result shows that the static friction force is directly proportional with the normal force. We can also see that the graph relationship between the static friction force and the normal force is related to some factors that's affecting the frictional force, which is first, these forces are mainly affected by the surface texture and the amount of force impelling to them together. And second, the angle and position of the object affect the amount of frictional force. These experiments need to be done in 3 trials for each mass because we need to get the average results. Repeating an experiment is important to verify that your results are consistent and not just uncertain. In this experiment, it also is possible for an error to occur as a result for a few things. For instance, if inconsistencies in surface. The surface were not all the same. Depending on how rough or smooth the surface was, the different readings for the force would result. Because of that, it is advised to stick to few surface only so that the result would be consistent.
For the question, the first is how can anti-lock brakes stop a car in shorter distance than regular brakes? The ABS stop will lock up an uncontrollable slide by applying and releasing the brakes. In braking situation, a vehicle without ABS might experience will lock up. ABS often offer a more rapid control stopping distance. For second question, from the experiment, which material has the highest coefficient of steady pressure? Does it agree with your hypothesis? What do you intend to determine the coefficient of steady pressure? The answer is rubber material has the highest coefficient of steady pressure. This can be accepted as our hypothesis is to determine the coefficient of steady pressure in different surfaces. To determine the coefficient of steady pressure, put two objects together and tilt them until the top one slide. For the third question is, once the mass begins to slide, does it move smoothly or does it undergo stop and commotion? Explain the motion. The answer is due to frictional force. When an object slides over a surface, it usually slows down quickly because whenever one moves or try to move over the other in direction so as to oppose a relative motion on the surface. This is called rolling and simple motion.
So in conclusion, by conducting this experiment, students can determine the coefficient of static friction in different surfaces. A wooden block being placed that has a rubber surface creates a little static force on the table. On the other hand, it generates a high friction force on a non-rubber surface. The outcome, however, might contain some error because the table surface might not be totally smooth. With a rubber surface, the static friction coefficient is better than without.